Let's look at two different approaches for constructing interactive histograms in R. In the first approach, we use ggplot2 to create a basic histogram, and then use the ggplotly function from the plotly package to make the graphic interactive. We're going to use the penguins data set, and specifically we're going to create a histogram of the bill length millimeter variable. So in this code right here, I am creating a ggplot using the penguins data set, and then I am adding a histogram geometry by associating the bill length millimeter variable with the X aesthetic of the graphic. I then assign this the name gghist. This is actually a really important step. The particular name doesn't matter, but it's very important to save this graphic because I need to feed that object into the ggplotly function. And when I do that, I get the graphic below. This graphic looks like a standard ggplot2 histogram, but the difference is that when I hover my mouse over the bars in the histogram, I can see the midpoint associated with each bar, as well as the count associated with each bar. So for this particular bin in my histogram, there were 19 penguins with a bill length between this lower bound and this upper bound right here. Creating a similar histogram using the plotly package is not that difficult. So we're going to create a similar histogram using the plot_ly function, which is the main function that you use to construct interactive graphics in the plotly package. We're going to set the type argument of the plotly function to histogram so that we know we want to construct a histogram. We're going to associate bill length millimeter with the X attribute of the plot. And we don't have to do this, but we're going to set the in_bins X argument of the function to control the number of bins in the histogram. If you don't specify that argument, then the plotly function will automatically make a choice about the optimal number of bins that you should use. So we feed our penguins data frame into the plotly function. We use the tilde notation to associate bill length millimeter with the X attribute of the plot. We indicate that type equals histogram, and we also specify that the number of bins for our histogram should be equal to 30. When we run this code, we get the following histogram, which produces somewhat similar information to the interactive ggplot. In this case, we can see the endpoints of the bins instead of just the midpoint, but we also have the counts associated with each bin. So for this particular bin, we see there are 13 penguins with a bill length between 35 and 35.9 centimeters. If you look carefully at this histogram compared to the previous histogram, you can see that there are some differences. So for example, if we focus just on the right tail over here, we can see that it's not quite the same. And the reason is because the two plots use different endpoints to delineate the bins that are constructed for the histogram. If we want the two histograms to be the same, then we have to do a little bit more work. And so I'm going to show you one approach to doing that. So what we're going to do is we're actually going to pull the data that was used to create the histogram by ggplot2, and we're going to store it in a data frame. And the way that I get that data is using the layer_data function. So I take my ggplot2 histogram that I had previously saved, I use the layer_data function, and I'm going to assign that the name datahist. And there's actually are lots of pieces of information in this data set, but the ones we care about are the xmin variable, which describes the lower bound or the lower endpoint of each bin that was used to construct that histogram. And the other piece of information I'm going to obtain is I want to know how wide these bins are. And the way that I get that information is by taking the difference between this number and this number right here. Or in R, I can use the diff function to automatically take the differences of successive points in a vector. So I'm going to take that xmin vector, I use the diff function, and then I'm going to use the head function because I don't need to see that many. But what this tells us is that the difference between this lower endpoint and this lower endpoint is 0.9482759. So what I'm going to do now is I'm going to specify some additional arguments in my plotly function. So I need to specify the xbins argument, which is a named list, which means that the elements I want to provide to that argument are actually going to be part of a list, and each element of the list has to have a specific name so that the function knows what to do with that information. And the two pieces of information that I need are start, which is going to be the lower left endpoint of the histogram, which is 31.76724. I got that from up here. And then size, which is going to be the width of the bends, which we have previously computed to be 0.9482759. So I add that information to my plotly function, and when I run that code, I get this histogram right here, which if we compare this to the histogram produced by ggplot2, should be identical. The color is different, but because we use the same bin links, the counts and bin endpoints should be exactly the same as for the ggplot2 histogram.